In preparation for the next thing that we're going to do, we're just going to review quickly about inverses and multiplying matrices. And so this video is just to help you remember the things that you've already learned. The first thing that we're going to review is multiplying. And so if you remember when we multiplied matrices, in order to tell if you can do it or not, you have to look at the dimensions. And so I've got these two matrices right here to multiply. And if you look, we've got a 2 by 2 matrix on the left and a 2 by 1 matrix on the right. Remember, it's row by column. Okay, and so in order to tell if you can multiply it, the inside dimensions, so this that's marked in red, those have to match. And as long as they match, then you can multiply. And then the answer will be determined by the two outside dimensions, this 2 and this 1. That tells us what our answer is going to look like. So that's helpful when we go to find our answer. So we can go ahead and multiply these. And so the way that you do that is you are going to multiply the first row by the first column, and we're going to multiply them and add together. So we've got 3 times 3 plus 2 times negative 1 in the yellow. And then we're going to do next the second row by the first column, and so we've got the negative 2 times 3 plus the 1 times negative 1. And then we're going to simplify that, and we get our answer matrix, so 7, negative 7, and that's the product of those two matrices. Next example, we've got a 1 by 3 matrix and a 3 by 2 matrix. Because the inside dimensions match, the 3's match, we can multiply, and our answer will be a 1 by 2 matrix. So think about what that looks like, 1 row, 2 columns. So going ahead to multiply those, we're going to do the first row, which is the only row, times the first column. And then we are going to do the second row, the first row by the second column. And then we're going to simplify that. And so we get our answer, negative 1, negative 4. So go ahead and pause the video if you need to and make sure you remember how to do that. Okay, the next one, we're going to have these two matrices here. We've got a 2 by 1 and a 2 by 1. You notice that those dimensions do not match on the inside, and so therefore the product is undefined. We are not able to multiply those, and so there's nothing to do. Okay, next we're going to review finding inverses of matrices. And so if you have a 2 by 2 matrix, you've got the matrix A, which is A, B, C, D. And to find the inverse of that, remember you do 1 over the determinant. Don't forget to do the 1 over part. And then you do this switched around matrix, as I've called it, okay, where you have to switch that around to find the inverse. And so let's do a practice problem or two. So we've got matrix A, as listed here in your notes. And so to find the inverse, the first thing we're going to do is find the determinant of A. So if you remember, you do that by multiplying 1 times 2 and subtracting the product of negative 4 times 2. And so I'm going to get 10 from that. Now that is the determinant, so I'm going to do 1 over the determinant. So you'll notice that this right here goes right down there, so it's 1 over the determinant, and then you do the switched around matrix right there, where we swap those two values places, and then the signs change on those two parts right there. And then you just multiply, so 1/10 times 2 is 2/10, and we could write that as a fraction, reduce it to 1/5, negative 2/10, 4/10, and reduce that, and 1/10 and reduce that. You'll see them sometimes as decimals, sometimes as fractions. Usually as fractions, but this one is an easy decimal, so I'll just leave it like that. Okay, so that's the matrix, that's the inverse of the matrix. Okay, second example, if matrix A is 4, negative 2, negative 6, 4, let's find the inverse. So first we find the determinant. So you're going to multiply the 4 times 4 and the negative 6 times negative 2 and subtract. So 16 minus 12, and that's equal to 4. So 4 is my determinant. At any time, pause this if you need to stop and catch up. I'm just going quickly because you already know this. The inverse then is 1 over the determinant, and then you're going to do the switched around matrix. So these two numbers change places. Of course, it doesn't look any different because they're the same number. And then the signs on these two changed from the original. Then you're going to do 1/4 of 4 is 1, 1/4 of 2, so 1/4 times 2, and that's where you get the 1/2. 1/4 of 6, and that reduces to 3/2. If you put it in your calculator, you get 1.5. And then 1/4 of 4 is 1. And so this right here, that's your inverse.